Alright, so in this video, we're going to talk about the worksheet 9.3A level 2, the joint variation. So first of all, to understand something with the first one is, if the z is various jointly as x and y, so basically you can just write it as z is directly proportional to x times the y. So the second one is, if one thing is directly variate and the other one is inversely proportional to, so we have the z is various directly as x and the other one is inversely as y. As I said before, when you see the inversely, you can change it back to directly, and the y can change it to 1 over y. So we have the z is proportional to x times 1 over y. So the third one we have is z is various both inversely as x and inversely as y, which means that you can write it as the z is proportional to 1 over x times 1 over y. So if you have the idea of these three formulas, then we can do the rest exercise. So first of all, we can do the question 1. The question 1 is asking about to write it in a formula that's with the variation constant k. So a lot of students in the class didn't write into a formula. They just give me the proportional sign, so which is not the question is asking. So first one, we have the z is jointly as a and b, so which means that the z is various directly as a and b, then we can write as the z is proportional to ab, which means that the z is equal to k times a times b. So for b, we have the z is jointly as x cubed and y squared, which means that we can write as the z is proportional to x cubed times y squared. Then we can write as the z is equal to kx cubed y squared. So for c, we got one part is directly, the other part is inversely, so we can change the inversely to directly and the v squared to 1 over v squared. So which means that we can write it as the z is directly proportional to u, and the inversely one can change it to 1 over v squared. And we combine them, change the proportional sign to equal to k, then we have z is equal to ku times 1 over v squared. For part D, we have inversely as p, directly as q squared. So for this one, it can change to 1 over p. Then we have the z is proportional to 1 over p times q squared. And we change the sign to get z is equal to kq squared over p. For part E, we have both of them is inversely, so we change all of them to their reciprocal to get z is proportional to 1 over square root m times 1 over n, which means we have z is equal to k divided by square root m times n. Next, part F, we have z is jointly as the cubic root and the square of t. So cubic root means that, so the cube root of r means that the cube root over the r. So it's both jointly, so it means that they are both directly to them. Then we have the z is proportional to the cubic root of r times t squared, which means that we have the z is equal to k cubic root of r times t squared. Then we have the g, we have the first one is inversely as x and inversely as the square of y. Then we have both taking its reciprocal, then we have the z is proportional to 1 over x times 1 over y squared. Then we have z is equal to k over ky squared. So that's for the first questions. Then moving to the second one, we have the question is saying that z is various as x and y, which means that we can have the z is proportional to x times y, so that we can write as z is equal to kxy. Then the condition is we have x is equal to 3 and y is equal to 4, z is equal to 1, 3, 2. So then we can substitute the x, y, z value into this equation to get the value of k, which means we have 1, 3, 2 is equal to k times 3 times 4 which means k is equal to 132 divided by 12 to get 11. So every time you get the variation constant, you must to put it back in here, which means z is equal to 11xy. So that's the relationship between x and y. So after that, we need to find out the value of z when x is equal to 5 and y is equal to 2. So the question is asking when x is equal to 5, y is equal to 2, what's the value of z? Then we can substitute the x value and the y value into our equation. Then we can have the z is equal to 11 times 5 times 2, so the answer is equal to 110. Okay, so moving to the question 3, we have that the z is various jointly as x and y squared, which means that we have z is proportional to xy squared. Then we can say that we can change this fishing sign to be equal to k. Then we have z is equal to kxy squared. And the condition is x is equal to 6, y equal to 2, z equal to 3. So we substitute back in. A lot of students forgot to write this squared, okay? So make sure that you follow the questions. Question saying that it's jointly as x and y squared. So make sure you put this squared. Then we have the 3 is equal to k times 6 times 2 squared, which is substitutes the x here, and substitute the y here and squared it, and the z put at the left hand side. Then we can have only k as the only variables, so we can solve it to get the, so we have the 3 is equal to 6 times 4 giving 24k, then k is equal to 3 over 24. After simplifies, you can get 1 over 8. So after you got this k, you need to substitute back into the original equation. Then we have the z is equal to 1 over 8 xy squared. So that's the formula connecting xy and z. So now the question is asking when x is equal to 4 and y is equal to 10. So we have the x is equal to 4, y is equal to 10. So what's the value of z? So that we just substitute the x to be here, the y to be here. Then we can get our z is equal to 1 over 8 times 4 times 10 squared. Then we can get our z is equal to, so 10 squared giving you 100. 100 times 4 give you 400, divided by 8 squared give you 50. So the answer would be 50 for question 3. So now moving to question 4. The question 4 is saying that we have the z is various directly as x and inversely as the square root of y. So inversely can be changed to directly, and we change the square root y to become 1 over square root y. So which means that we can change, we can have the relationship between the z, x, y should be the z is proportional to x times 1 over square root y. Then we change our fishing sign to become equal to k. Then we have z is equal to kx over y, over square root y. Then the condition we have is x is equal to 6, y equal to 4, then z is equal to 15, which means that we can substitute these three values back to this formula to get the value of k. So we have 15 is equal to k times 6 over square root 4, which means that the k gonna be equal to 15 times the 2 divided by 6. So we can have the k is equal to 5. So the square root 4 giving you the 2, so you move this 2 back to 15, then we have this 15 times 2. So we're moving back the 6 to the left hand side, so we divide by 6, then we can get the value of k, which is equal to 5. So every time we got the variation constant, we need to keep it back to our original formula. Then we have the z is equal to 5x divided by square root y. So this is the equation what we want to find. So never stop just finding out this variation constant. So you have to find the equation link the x, y, and z. Okay, so now we're moving to 4b. Now they're asking to find out the value of x when y equal to 9 and z equal to 12. So we're back using our equation connecting x, y, and z. Then we can have the z is equal to 12, the x we need to find it out, and the y value is equal to 9. So we just substitute the y and z values then we can say that the 12 is equal to 5x divided by 3. So we move this 3 to the left hand side, we can get 36 is equal to 5x, which gives you the x is equal to 36 divided by 5, or is actually equal to 7.2. Okay, so now we're moving to next question, question 5. Now we have the a is varies inversely as the square of b and inversely as c. So inversely changing to directly, then the square of b means that you can change into y over b squared. So inversely change to directly, then we have the c being 1 over c. So now the relationship between a, b, c, we have a is proportional to 1 over b squared times 1 over c. And now we change the Fishing sign to become equal to k. Then we have a equal to k divided by b squared c. So the condition that we have is b equal to 1, c equal to 8, and a equal to 0.5. As again, we substitute the values here to get the 0.5 is equal to k divided by the b squared, which is 1 squared, times c, which is a. So the k value is going to be equal to 0.5 times 1 times 8, giving you 4. So every time you find out the value of k, what you're going to do is to put it back to the original formula, which means that the a is equal to 4 divided by b squared c. So this is our question A, that we find out the relationship. We express the a, so we express this a in terms of b and c. So we link a, b, c in one formula. So question B, we have the value of a. We need to find out the value of a when b equal to 2 and c equal to 3. So we basically just substitute this b equal to 2 and 3 back to our formula here. So we have the a is equal to 4 divided by b equal to 2. So 2 squared times 3. So the value of c is 3. So using a calculator, you can get is 4 divided by 4 times 3. So a is actually just equal to a third. So for question C, we need to find out the value of c. But basically, we're just substitutes the value of a and b back to our original formula. Then we can have the a value is 5, which is equal to 4 divided by b value, which is 4 squared times c. So now we can do some elimination. In this part, we don't want this 4, we don't want this 4. So we're left on the numerator is just 1, and on the denominator is 4c. So we move the 4c to the left hand side. Then we can have is 5 times 4c equal to 1. Then we can have 20c is equal to 1, which means that c is equal to 1 over 20. So now we find out the value of c. Okay, so this is the answer for question 5. And now moving to question 6. So lots of students find this is very hard, but just trying to do them step by step. So first of all, we got this relation z is proportional to x squared y cubed. So we can write it as that z is equal to k times x squared y cubed, where the k is a non-zero constant. As we have this relationship, then we can change the x squared y cubed divided by z is actually equal to 1 over k. If you think this is too fast, you can do more one step. So first of all, we can just change the x squared y cubed back to the left hand side. So we divide by x squared y cubed over the z. Then we have z over x squared y cubed is actually equal to k. Then we swap the numerator and the denominator to get the x squared y cubed over z is actually equal to 1 over k. So as k is a constant, which means that 1 over k is also a constant. So that we have the 1 over k is also a constant, which means that the question is requiring x squared y cubed over z is also a constant. So for question B, they're asking when x is decreased but y is increased, z must be increased. So is this actually true? So for example, if I think because we have z is equal to kx squared y cubed. So let's think about it. When x is decreased but y is increased, is this z must be increased? So for example, if x is just decrease a little bit, but the y is increase a lot. So overall speaking, the z will be increased as well. However, we take another scenario. If the x is decreased a lot, maybe like 100 times, but the y is only increased for like 10%. So the z must be decreased as well. So actually in this question, it's not a must be increased. It can be increased, but not must. So it's actually depends on how x is decreased and how y is increased. It depends on the percentage how x and y is being changed. So answer for 6b is gonna be false, and for 6a is gonna be true.